think in the interest of time, let's start. And um I believe some people may be having some issue. I think finding the password. So I have requested the team to send it separately so that they are able to join. Okay. Hi. Good morning and good afternoon to people. I am Satish Kumar. I'm the Executive Director and President of the Alliance for an Energy Efficient Economy. And I'm speaking to you from Montreal. I'm here to attend the IEA conference on energy efficiency. So, a very warm welcome to everyone who has taken time to participate in this webinar. And on behalf of AEEE and ACEEE, I welcome all of you to this webinar on strategies to decarbonize the Indian cement industry. AEEE together with ACEEE has jointly developed a roadmap for the cement sector's decarbonization from both the supply side interventions as well as we have looked at the demand side opportunities for low carbon cement adoption through stakeholder consultations with developers, builders, and architects and other key stakeholders. The agenda for today's webinar is that we will have a couple of presentations by my colleagues and collaborators at ACEEE. So, Brijesh Pandey from AEEE will be making a presentation on the report, and then that will be followed by another short presentation from Pavitra of ACEEE, and she will be presenting on the international policy sections and what are some of the key developments there and how is India doing and what are some opportunities for further improvements on the policy front. Once the two short presentations are made, we will have a panel discussion and we will be joined by a group of eminent experts. But before I introduce the panelists, let me first invite my colleague Brijesh Pandey for the first presentation. So over to you, Brijesh, for the presentation.
So, good afternoon, everyone. I hope my screen is visible to all of you.
Yes, it is.
Yes.
So, I will first present the background of the Indian cement sector, and then I will describe the different key levers and the strategies that we have selected to decarbonize this sector. And after this, Pavitra will be presenting the evolution and the policy development that is currently happening in other parts of the world to decarbonize the cement sector, and how some of the policy initiative and intervention India can adopt based on the condition that suits to its sector. And after that, we will have a moderated panel discussion based on this presentation. So a little bit about the context and the landscape of the Indian cement sector. So India is kind of second largest producer and consumer of the cement globally. And in the financial year 2024-2025 itself, we have produced around 427 million metric ton of cement and consumed around 435 million metric ton. And the production of this cement required a thermal energy consumption in the range of 312 petacalories, whereas the electrical energy consumption was around 26.8 petacalories. And if you combine the emission associated with this energy consumption, it's turned around 290 million metric ton of CO2 emissions. And when you see the bifurcation of the electrical energy, the energy consumption required at the plant level, so you can see that around 90% of the 92% of the energy is associated with the thermal energy consumption, whereas the 8% of the energy is required to electrical energy consumption, which is basically used for the grinding purpose, material handling, as well as the auxiliary plant operations. And if we further bifurcate the emission from the cement sector, So it basically divided into the three categories. First is the calcination process, which is the heart of the cement manufacturing process, and it is the kind of chemical reaction where limestone is converted into lime and CO2 is produced as a byproduct. And you can see that the majority chunk of the emission happens during the calcination process. Then the second comes regarding the fuel combustion, that is basically used to heat the kiln. And then the remaining 12% is associated with the electricity consumption that basically used during the grinding and material handling processes. So coming to why decarbonize the cement sector. So we all know that India is a developing country and it continue to build its infrastructure. And if you take the example of building sector itself, which currently consumes 75% of the cement produced in the country, including the residential and commercial building both. So there is a projection that India is going to double its building floor space by 2047. And apart from the building construction, there are other construction activities happen like road and infrastructure. And to meet the demand of the cement in those construction activities, India is projected to triple its capacity by 2050, which is 1,350 million metric ton of cement production. And and there are projections that the emission associated with this consumption is around 495 to 787 million metric ton of CO2, depending on the demand that goes into the construction activities. So if you continue to manufacture the cement in the way that we do today, it is going to create a huge impact in terms of environmental damage. And also, we need to fulfill our commitment for net zero as is given by our Honorable Prime Minister, as well as there are development happening in other parts of the world. If you take the example of European Union, which has implemented the CBAM, which kind of regulates the imported material that come into the European Union region. And India is a kind of exporter country which export the cement into the European Union nations. So if India is like to continue its export of cement to the European Union nation, it has to decarbonize its cement manufacturing process. As well as at the national level, also there are ESG compliance, which a lot of developers need to fulfill. So they are also looking for the alternative low carbon cements which can fulfill their ESG goals. And apart from this international policy development in ESG compliances, there is a need for the circularity and the resource security at the national level itself. So to fulfill this goal, we need to decarbonize this sector. And to decarbonize this sector, under this study, we have presented five levers. And these levers we have selected based on the maturity of the invention, maturity of the technologies, cost involved for the implementation of those strategies, and how ready the sector are to implement those strategies. So based on this supply chain cost policy level support and the maturity of the different resources and strategies, we have sequence these levers in a strategic manner so that the low hanging fruit can be which are easy to implement and cost effective can be taken first, and then those which are kind of currently maturing and the cost intensive strategies can be taken at the later stage. So first lever that we have presented is the alternative fuel substitution, which is kind of replacing the current conventional fuel that are being used at the plant level with the alternative sources like agro and bio waste fuels, as well as utilizing municipal solid waste as an alternative fuel. And we have estimated that if the current thermal substitution rate of the plant is increased from 6% to 20%, then it has a emission abatement potential of roughly around 21 to 24%. The second lever that we have selected is the clinker factor reduction and the use of supplementary cementitious material. So you all know that clinkerization process is the kind of heart in the cement manufacturing process and which also kind of contribute most in terms of emission. So how to reduce the clinker factor in the cement itself and use the supplementary cementitious material. And there is estimate that if we reduce our clinker factor ratio, which is currently 0.73 to 0.63, then it will offer betterment potential in the range of 7 to 15%. The third lever that we have selected is the energy efficiency improvement. So we are calling it as a foundational lever because in India, the cement manufacturing plants historically have reaped the benefit of energy efficiency improvement due to the different policy support like PAT and currently the CCTS. And a lot of cement manufacturing process, manufacturing plants are already operating at their maximum efficiency level. So the further improvement in energy efficiency will lead to an incremental benefit in terms of emission reduction, but it will not kind of have a transformation impact in terms of reducing the emission at the plant level. So we have called it as a foundational level because it is essential to have, and it will pave the path for the other levers that we have mentioned in this study. The fourth lever that we have mentioned here is the decarbonization of electricity use. And in the report, we have talked of decarbonization of electricity use from both supply side as well as the demand side. And we will go deeper, like what can be done for the supply side and what can be done from the demand side, and what is the trade-off of doing that. And the fifth lever is related to carbon capture, utilization, and storage. This lever is currently in the piloting phase and the technology is maturing. So we have kept it as a last lever. But in the next coming decades, when the technology will improve and the commercialization will be feasible, then the CCUS will serve as a backstop or ultimate solution which can reduce the unavoidable emission that happens during the cement manufacturing process. So now coming to the each lever in detail. So so little bit background about each lever. So current status for the alternative fuel substitution is that Indian plants are currently running at the 6% TSR rate, whereas in European Union the average TSR rate is 50%, whereas some of the individual plant has shown 90% of the TSR rate. And the recently released Niti Aayog report mentioned that if the Indian plants will increase its TSR rate from 6% to 20% by 2030, it will yield 80 million ton of CO2 emission reductions. Then why it is not happening? India is a country where we have an abundance of agri bio waste as well as the municipal solid waste, but we are not able to utilize those waste because the Indian cement plants, they are getting the waste is kind of varying degree of calorific value. And also the waste that they are getting is not segregated at source. So the manufacturing plant needs to invest at the plant level so that they can do a segregation at their plant level. But this involves a risk because these plants are not kind of reliable on the supply chain that is currently there on the agro bio waste as well as the municipal solid waste. So because of this uncertainty, they are not able to kind of take a risk to invest at the segregation facility at the plant level. So what kind of regulatory change is required? So in the report, we have proposed that there could be a single window clearing platform which can create a system where the fuel which are kind of suitable to use in the cement manufacturing plant can be streamlined, and the supply chain can be strengthened so that the cement manufacturing uh, plant have the reliability on the supply chain issue, and they can make the investment, to do segregation as source and utilize this municipal and agro waste to increase the TSR rate from the 6% to the projected 20%. The second lever is the clinker factor reduction and the use of supplementary cementitious material. And as you know that clinker production is kind of contributing 85% share in the cement manufacturing process. And if we reduce the clinker ratio, which is currently 0.73 to 0.63, this will lead to the 7 to 15% of abatement potential. And the dominant cementitious material that is there in the country is the fly ash and the granulated blast furnace slag. And also, with the current development on the port side, calcinite clay is also being considered as a dominant cementitious material. And because of that, there are few alternative cement, which is a kind of blended cement, which are utilizing the different cementitious material are LC3 cement, pozzolana Portland cement, and pozzolana slag cement. But the problem is here the continuity of getting this supplementary cementitious material. Right now, the fly ash and the 25% of the fly ash that are currently being produced in the country is taken by the cement manufacturing plants, and the 100% of the slag are being consumed by the cement plants. But India is planning to kind of phase down its coal-based thermal power plant and also move away from the blast furnace route of steel production. So the continuity of this supplementary cementitious material is going to decline over the future of time. So what kind of other sources of supplementary cementitious material can be factored in, and how these manufacturing plants, cement manufacturing plants, are ready to take up those supplementary cementitious material. So those are the kind of priority areas where we need to think of, and how to create awareness on those fronts so that the calcinite clay based supplementary cementitious material based cement can be uptaken, and how this can be utilized in the construction process and the infrastructure project. The third layer is on energy efficiency improvement. So as I have mentioned previously that India has already reaped the benefit of energy efficiency at the cement plant level. And you can see there are the different method that has been presented which improve the energy efficiency at the plant level. For example, the dry process kilns with multi-stage preheaters and pre-calciners, and then the use of vertical roller mills for the grinding and material handling process, and then use of advanced automation for the process control. And here we have compared how the different schemes has resulted in India. So we have given the example of PAT, and under the PAT 5 scheme, the 12 designated consumers, so they have been assigned the reduction target of 0.87 million ton oil equivalent, and and those designated consumers basically achieve more than that. So the actual saving was 0.153 million ton oil equivalent, and the electrical saving was around 1.78 million units, and which resulted into the CO2 emission reduction of 0.61 million ton of CO2 equivalent. And going forward, since the battery is being passing from the PAT scheme to the CCTS scheme, so under the CCTS scheme, currently 186 cement manufacturing plant has been notified, and they have been given the cumulative target of 7.179 million tons of CO2 equivalent. And we need to see how this cement manufacturing plant will achieve this target with the different strategies proposed in the different decarbonization roadmap that are currently going on in India. And fourth lever is the decarbonization of electricity uses. So the electricity, so in the report we have talked about the decarbonization of electricity uses from the supply side as well as from the demand side. In the supply side, we have talked about the use of renewable energy sources like like solar and windmill as a captive power plant, so that the share of electricity can be increased from the renewable sources. And on the demand side, the use of efficient manufacturing process like the dry process kiln, the vertical roll millers, and the use of automation to kind of reduce the demand, reduce the electricity from the demand side. And in the supply side, we have mentioned about two strategies. One is on the use of renewable energy sources, and second is the utilization of waste heat recovery system. And as we kind of going to improve our energy efficiency, and also as we have discussed in the previous slide about the use of alternative fuel sources to increase the thermal substitution rate of the plant. So there is a energy paradox here. So if we are using the conventional fuels, then because of its high calorific value, it produces exhaust gases at certain temperature limit with certain heat capacity. And when we are going to substitute that conventional fuel with the agri bio waste fuel and the municipal solid waste fuel, then its the calorific value will decrease, and because of that, the temperature of the exhaust gas and the heat capacity will reduce, and therefore the utilization of waste heat recovery system will reduce. So how to navigate this energy paradox, so that on one hand we can keep improving the energy efficiency, keep using the alternative fuel to kind of reduce the emission intensity at the plant level, as well as on the other hand how to take or how to leverage the benefit of the waste heat recovery system. So in the report, we have mentioned that waste heat recovery system can be utilized as a short to medium term lever, where we can utilize the full potential till we reach to the thermal substitution rate of beyond 20%. But when we kind of keep increasing our TLSR rate from 20% to 25%, 30% and beyond, then the impact of waste heat recovery system is going to reduce in future. So the benefit to leverage the waste heat recovery system is now, and its potential is going to be decreased in over the future of time. And now coming to the fifth lever, which is the carbon capture, utilization, and storage. So as I mentioned, that this technology is currently in the piloting phase, and it is the kind of maturing technology. So the Indian cement manufacturing plants are kind of not currently ready due to the technological limit and the cost barriers to implement this carbon capture and storage technology. But as this technology matures and the commercialization of this technology will be feasible, then definitely this will serve as a backstop to reduce the unavoidable emission during the cement manufacturing process. So as you recall that in the first slide, I mentioned that the most of the emission happens during the calcination process. So no matter how energy efficient your plant is, or how like you can increase the TSR rate of the plant, but the emission that happens during the calcination process is going to be there. And the CCUS will be a technology through which we can capture those emission and utilize through carbon as a service model. So, so these are the levers we have talked about from the supply side, but also we have assessed how the market is ready to take the low carbon cement or the alternative supplementary cementitious based cement or the blended cement. So we have conducted a stakeholder consultation with the developers, architect, and the material manufacturers also, to kind of understand what are the challenges they are facing and why the uptake of low carbon cement has not been materialized in India. So the first barrier that we have listened from the stakeholder consultation is the standardization and the certification. So you must be aware that there is a BIS standard for the production of LC3 cement, but there is no BIS standard for the for the construction process using the LC3 cement. So there, so there is a perceived kind of uh, a threat related to reliability and the strength of this blended cement or LC3 cement. And because of that, developers are not kind of ready to take those alternative and blended cement in the construction process. But at the same time, there are examples available where this low carbon and blended cement has been used. For example, if we talk about the Jewar airport, where they have utilized LC3 cement for and then the second thing that we have heard is the demand pull mechanism. So how to create a demand? So if we let's say if you want to mainstream this low carbon cement, then there is need to be a green public procurement through which the market pull mechanism can be created and the manufacturer get a constant demand for those low carbon cement. Then we have also heard that there are no extra financial incentives. So most of the developers do the green sustainability related things because they get incentives in terms of FAR. But they have mentioned that there is no kind of extra benefit available if they are using the low carbon cement or the blended cement. Then we have also heard that there is a need for technology demonstration project through which the evidence can be created so that the developers and the builders start taking those low carbon cement and then the bulk procurement process. So we have also discussed with the different builders association like Naritco and Credai, where we have heard that there can be a bulk procurement process through those developer-led association to kind of bring down the cost that is associated with those low carbon cement. And then last is the awareness and training program about this low carbon cement and the supplementary cementitious material. Now I will hand over to Pavitra to go for the global policies and how this can leverage by India to further decarbonize its cement sector.
Thank you, Brajesh. As Brajesh covered all the different technology approaches in the previous part of the presentation, I just want to share a little bit more about this project where we also started looking at policies for cement decarbonization across the world in several different countries. The main approaches that we focused on were alternative cements, alternative fuels, waste heat recovery, carbon capture, utilization, and storage, electrification, renewable energy use, energy efficiency, clinker reduction, and of course, demand reduction. In order to make these technology approaches work to their best ability and to actually support market transformation, there are a variety of tools that each of these different countries have also adopted. These include regulatory mandates and frameworks that can provide rules and enforcement mechanisms for the market, standards for low carbon cements and products that help ensure that these products actually are mainstreamed across the market. Green public procurement to aggregate demand and send strong demand signals to suppliers. Pilots and demonstrations to build market confidence. Market-wide stakeholder engagement, a very key piece that is important to build market acceptance of these new technologies. Carbon pricing, again, to send signals. These could take the form of emissions trading systems, cap and trade, or cap and invest, and innovative financing models through grants, credits, public-private partnerships, or blended finance. Next slide, please. So in this graphic, we are going to cover a couple of different things. One is we're going to look at some market characteristics that differentiate some of these countries that we assessed, as well as look at some of the most successful strategies employed in each of these countries. So the countries that lie below the green dotted line, Brazil, Thailand, Malaysia, Vietnam, and Indonesia, all share certain market characteristics with India, in that they have high urbanization rates, there is heavy infrastructure investment as these are growing economies, and there's a high market share for bagged cement products. Conversely, when you look at countries in the EU or the US, They are predominantly dominated by ready mix or bulk ready mix concrete or bulk cement. And they also tend to rely on economic tools and innovative financing models. So, looking at specific countries now and some of the most successful strategies in the EU, as Brajesh previously mentioned, alternative fuels have been highly successful. They've achieved an average TSR of 56%, with some plants going as high as 90% in Germany and Poland. They also have a high clinker ratio achieved of about 74 to 77%. So they've been very successful at that and have almost 20 plus years of experience with carbon capture, utilization, and storage. And there's a lot of great lessons to be learned from there as India starts down the path of deploying CCUS. Regulatory mandates have been highly successful. Everyone knows that about the EU. They've been able to set up their emissions trading system and, of course, the carbon border adjustment mechanism. So carbon pricing has worked well in that market, as well as using innovative financing approaches. In the US, they've had good success deploying green public procurement across several different states and conducting pilots and demonstrations of new materials and new products, both on the public sector as well as the private sector side, as well as employing certain innovative financing mechanisms. When we look at countries like Brazil, they have been able to leverage renewable energy to green their grid through the use of hydropower, which has really driven down emissions from the cement sector. They have been able to use low carbon standards for low carbon products and use innovative financing and innovation hubs to drive the experimentation around alternative cements. Vietnam is another country which has really been able to leverage regulatory mandates like the EU. They've set up a cap and trade system and very successfully mandated waste heat recovery systems. They have, in fact, also achieved a TSR of 40%, which is one of the highest rates in the global south. They've been able to push for pilots and demonstrations for alternative fuels, and that's what has helped with their TSR improvements. Thailand has been conducting pilots and demonstrations of CCUS, another country from which there are some lessons to be learned, and has done a great job with stakeholder engagement across the entire market spectrum. Malaysia, with its high infrastructure needs, like all these other countries, and as like India, has been able to set up and very aggressively pursue green public procurement. And Indonesia has benefited from setting standards for these low carbon products and is starting to more aggressively pursue green public procurement. So these various countries offer some lessons learned. There are additional details in our report, so I urge you to take a look at that. And with that, I'll turn it over back to Brajesh and Satish. Thank you.
Hi, thanks a lot, Brijesh and Pavitra, for the two presentations and talking about the salient features of the report as well as the I think the key findings and recommendations and the learnings from other I think best practices around the world. What I am going to do now is to dive into the panel discussion. Just give me 1 second as I pull up my notes here. Uh, just give me 15 seconds. Okay. So, so you have heard from the two co-authors of the report about what are the main levers of the decarbonization as the international best practices from which India cement manufacturing sector and the policymakers can learn. What I am going to do now is to facilitate a panel discussion consisting of experts who have been working, I think, in this sector for a long time. And let me start by introducing our panelists. The first panelist is Mr. Anurag Bajpayee. He is the director of Green Tree Global, and he will present the demand side perspective on adopting low carbon cement. The second panelist is Mr. Sabrish Elango. He is the program lead at CEW, and he will address some of the supply side interventions for the cement sector from a policy standpoint. The third panelist is Mr. Karthik. He is the Senior Program Manager at WRI India, and he has contributed to the recently launched Niti Aayog Cement Sector Decarbonization Roadmap. So we will look forward from his perspective for I think for his insights and perspectives on the panel. The fourth expert is Mr. Manjunath. Mr. Manjunath is the Vice President and Head of Business Development at JSW Cement Limited, and he will present the much needed manufacturer's perspective and plant level initiatives to decarbonize cement production in India. Next panelist is Mr. Vasudevan. He's a senior consultant at Terry with extensive experience in the cement sector, and he will discuss the technological feasibility of supply side interventions based on decades of work that he and Terry has been doing, I think, in the industrial space. And finally, Dr. Pramod Kumar Singh. He is also a cement sector veteran with over 3 decades of experience across manufacturing plants, and he will also discuss the technological readiness and the feasibility of supply side interventions. And Dr. Pramod Kumar Singh has also contributed to the development of this report. Gentlemen, very, very warm welcome to all of you. And I want to thank you for taking the time to participate on this important panel. Just before I start, for all the people I think who have joined in this webinar, if you have questions for the panelists, we will request you to put it in the chat box, and my team at AEEE is going to identify a few questions for the panelists, and we will pose those questions to the panelists, I think, at the end of the formal facilitation of this panel discussion. So let me start with the first round of questions, and I'm going to start with Karthik. And Karthik, you have been closely involved with the Niti Aayog Cement Sector Decarbonization Roadmap, and my question is related to the policy landscape that is currently existing in India, and what are the efforts that are being made. As I think the report has noted, that under the business as usual scenario, cement sector emissions could reach 495 to 790 million tons of carbon dioxide emissions by 2050. So from a macro policy perspective, what are the most critical interventions that are needed in the phase 1, 2025 to 2030, to alter this trajectory and reduce the emissions coming out of the Indian cement industry? Over to you, Karthik.
Thank you, Satish ji, and thank you AEEE and thank you ACEEE for having me as a panelist. WRI India was the knowledge product for the Niti Aayog Cement Decarbonization Report, which was released in January. While working on that report, we interacted with a wide range of stakeholders across the cement value chain. Based on those discussions, it became evident, even in your report, also it is clearly mentioned that these interventions are going to help us. The first one is that CCS. The second one is that increasing the TSR rate from 6% to the 20%. The third one is the increasing the reducing the clinker factor. That means increasing the supplementary cementitious materials. These are the three significant roles that already had been identified in that Niti Aayog report. Moving beyond this report, based on the continued interactions with various stakeholders, we believe the following interventions will equally important. The first one is the change in the standards. Now, if you go into the market, right now we are following the current perspective or instruction based standards. That means hey, if I want to do M22 1, that's what it is going to. It's not at the end of the 28, either it is a low carbon cement or high carbon cement, the standard, the performance, we need to see the performance. So we need to move towards to the performance based standards. That's the first intervention. It is going to help us. So this will encourage the innovation and enable the adoption of low carbon technologies and materials. The second one is that create the demand for the low carbon materials. For example, I will take the LC3 cement. LC3 cement code has been approved in 2024. Now we are in 2026. If we see any tender, there is no tender clearly specify that LC3 cement we could use it out. So uh, adopting in CPW one, that means rate scheduled rates. In the scheduled rates, the LCC cement is not yet been adopted. So changing these would help to create more demand for the low carbon materials. So public and private tenders need to explicitly encourage and mandate the use of low carbon material to create market demand. Finally, I would also highlight that behavioral aspect of procurement and contracting. For example, we had recently interacted with various contractors where they say that right now we had taken the brick manufacturing. In the manufacturing, people are using still OPC cement for making that concrete blocks. Just this is a demand side. We have taken an example only. So this in this OPC cement, people are using still. Sorry, in this big manufacturing, still people are using OPC. When we had asked them, hey, why you're still using OPC? You can use PPC or PSC. They say that we want to if we use a low carbon material or PSC cement, we need more time. So that's the reason people are not going it out. So I'm just giving an example of this. If you go to the developers, they also say that we want to move away from the contract, from that building construction as much as possible. So the third intervention is that procurement and contractual behavioral aspect has to be clearly mentioned even in this demand. So these are the three things that apart from already AAA has clearly convert what are the levers that is going to affect it out. So I have not discussed it out. To summarize my things, three things I would like to say that the first one is that performance based standards has to come in India, and the second one is that in the tenders or in it is explicitly mentioned both in public and private tenders, it should be explicitly mentioned low carbon materials. Thanks, Satish ji.
Thanks, Karthik, for highlighting the importance of, I think, performance-based standards and I think an intent to create like a level playing field so that all the manufacturers and all the procurement people, I think, are sending the right signals, I think, both from the supply and demand side. So thanks, Karthik, for that. Moving to Mr. Sabrish Elango. Sabrish, as Pavitra explained in her presentation, that carbon pricing is a mechanism that several countries are experimenting with and have also even adopted to accelerate the pace of decarbonization of the cement sector. In India, we are aware that there is a national carbon market framework that is under development and that will cover more than 175 designated consumers in the cement sector. So, will the current design of the Indian carbon market provide strong enough price signals and incentives to justify deep decarbonization investments and de-risk the high capex technologies? So, Sabrish, we would love to hear your thoughts on this.
Thank you very much, Mrs. Satish, and thank you to AAA for having me in this discussion. I'll get straight to the point. As far as I see it personally, I don't think that the CCTS mechanisms intended to drive deep decarbonization in any sector, let alone cement. The way that the system is designed is structurally meant to drive only marginal reductions in the emission intensity. And the reason this is the case is because unlike systems that are used abroad, this is not a cap and trade system. This is a baseline and credit system, which means that each plant is assigned an emission intensity that it has to reach the next year and the year after, and so on. So this means that if the targets are reached and exceeded, then the plant can trade certificates with people who have not reached their targets. So then the problem here is that the price of CO2, the nominal cost of each ton of CO2, applies only to the volume that is traded. So if someone is emitting 1,000 tons, someone is emitting 1,200 tons, and then the one who's emitting 1,200 actually has to reduce to 1,000, versus the 1,000 guy has already reached the target. That means the cost of CO2, whatever it may be in the market in the CCTS mechanism, will only be for the 200. Even if the cost of CO2 is $10 per ton of CO2, the $10 will apply only to the 200 tons that is being traded. So if you then average the cost of CO2 across the entire emissions of the industry, it'll be way less than 1, even if it's 10 nominally. The effective price will be less than 1. And from our studies, we know that even to adopt renewable power across the cement plants or adopt CCS, let alone, it will need a carbon price in the system, an effective carbon price across the entire CO2 emission of about 50 or more dollars per ton of CO2, which means that the nominal price will be that much higher. Comparing this to the EU ETS, the EU ETS also has allowances that have been provided, free allowances that have been provided to industries, but at least they have a phase out plan. By 2034, 2035, they plan to phase out allowances, which means that all industries will pay that market price for all CO2 that they emit. That is not the case in our system, which means, and we don't have visibility beyond 27, 28, where the targets have been set. We don't know what the targets will look like 10 years from now for us to even gauge what the price in the market could be, or whether the targets will be strict enough for us to achieve higher levels of decarbonization. So no, this mechanism will not be sufficient for deep decarbonization. However, it is very important to get everyone on board and start driving marginal decarbonization across the entire sector. We do need parallel mechanisms to drive deep decarbonization, to set up clean cement plants, to get market demand for clean cement, etc. The CCTS alone will not be enough.
Just very quickly, Sabrish, thanks for providing that distinction between cap and trade and baseline and credit. Uh, how do you see? I mean, knowing that EU ETS also had a bumpy ride and it has not been a smooth process, what do you see as a policy prescription or like a market mechanism that India should adopt to send the right signal through the CCTS program or any carbon pricing mechanism?
I think for the CCTS mechanism to be more successful, the targets have to be stricter. But for the targets to be stricter, it needs the industry to accept those stricter targets. But overall, that means that there needs to be parallel mechanisms aligned with the CCTS that will drive deep decarbonization. For example, if you're able to provide market signals, green public procurement is a way, for example, that's already been mentioned, market signals for procurement, then they know that even if they put in the higher investment for a product that will sell for a higher price, they will have the market for it, which means that they can sell whatever that market demands, and their average CO2 emission will come down by that much. Which means if it comes down by that much, then the targets under CCTS can become that much stricter. And whoever is unable to reach that target will have to pay more to trade the certificates. Similarly, we can have schemes where we add a surcharge on every unit of cement sold and use that surcharge to subsidize clean cement plants within the country. It's called a subsidy and recharge mechanism. So a mechanism like that could also work parallelly along the CCTS to create that initial wave of clean cement being produced and sold in the market. Either you subsidize that cement to make the price difference, the green premium go down, or you create a market demand so that the green premium can be absorbed by the market. So both of these things will support the CCTS by letting people produce the cement that is clean so that the average comes down by much more than what the targets are right now set at.
It sounds like a fee-based system, I think, that you are proposing, where I think the cleaner manufacturing facility are incentivized and
Yes.
the dirtier sort of like manufacturing are penalized. So thank you, Sabrish, for that. Let me move on to Mr. Vasudevan. He is a veteran. He has spent a lot of time, I think, looking into India's cement sector. So good afternoon, sir. And my question to you is that as Brijesh has noted in his presentation, that the cement sector faces an efficiency paradox of some sorts. And as kilns are optimized to consume less heat, the volume and temperature of exhaust gases decline and decreasing the potential for power generation through waste heat recovery systems. And what, in your expert opinion, should plant operators do for this long term trade off between thermal efficiency and waste heat recovery based power generation? Over to you, sir.
Thank you. Thank you. Actually, we had done seven sector roadmap, net zero roadmap, which was last year we launched it. So that focuses on the net zero of Indian cement sector by 2070. So it clearly tells that waste heat recovery is accounting for about 35% of the total, not 30, maybe around 15% of the total power requirement by the cement sector. That's what it accounts for. Now, the present situation, almost 95% of the fuel is coming from the coke or coal. That is what the industry is using. So, and over a period of time, now we are thinking about other fuels, alternate fuels, MSW, or changing the TSR, increasing the TSR to equivalent to EU or USA, all those things. So our situation is basically we have a combination of options. So we have combination of options where we can have to reduce the existing share of fossil fuels with other fuels like which was mentioned in this presentation, municipal solid waste or even industrial waste, etc. But what happens even if you do that? We are thinking about a substitution of 20% or 25% only. So we need to go beyond that level where actually is it possible to change this trend, making it a net zero fossil fuel, say going towards the other cleaner fuel options like waste biomass, like green hydrogen or electrification, etc. So these options are going to reduce, change the history, change the outcome from the cement plant, which is going to affect the waste heat available, which is waste heat is going to be available from the cement kilns. But in the present situation, what we see is almost we have actually conducted number of energy audits in Indian cement kilns, maybe 40-50 audits. We have found we cannot go below certain level of the temperature of waste gases, which is the bare minimum which is required. So it is not going to affect it, even if it is getting affected in the future, because if you are actually switching out to green hydrogen, see if the flue gas volume generated, almost 50-60% of the volume is coming from the process side, and 40% is coming from the fossil fuel side. So that is what actually it is going to reduce. So if that is going to get affected either in volume or in terms of temperature, so there is a possibility that if you want to have to maintain the waste heat recovery system, then there is a need for a supplementary fuel firing using alternate fuels. That is one option. Second option is basically you have to once it is reducing, then it is going to affect the entire thing. Then you will go moving more towards the renewable for future plants, less of waste heat recovery plants. Number two. Number three is if the temperature is coming down, then we should look out for some other new options like Rankine cycle or Kalina cycle, etc., which are actually still we are not using it. So those are the things which are the options which can play a role in the future. And if suppose some kilns are going towards electrification, all the flue gas generation is going to get completely, it is going to be eradicated. I mean, it is going to come down drastically. So we have to look for other options like renewable energy or what do you call low temperature waste heat recovery systems. Those are the options which we should look for. This is what our thinking is.
Okay, thank you, Manjunath sir. I thank you for sharing some of the technical challenges and complexities I think that are going to be involved, and also for highlighting some of the interlinkages I think between the technology, the fuel substitution that will be needed to continue the decarbonization journey for the Indian cement manufacturing sector. Let me, sorry, Mr. Vasudevan, I think
No
that,
problems.
yeah,
No
sorry
issue.
about that.
It's
Yeah,
all right.
so let me come to Mr. Manjunath ji. I think you are representing JSW Cement, and since among the panelists, you are also, I think, the lone person representing the cement manufacturing industry. So my question to you is that on the second lever, the clinker factor reductions and the use of supplementary cementitious material, the SCMs, I think there are some concerns. So how do you see future SCM availability presenting a growing challenge as India's planned transition away from coal will constrain probably fly ash supply, and also I think the availability of slag is going to be limited as I think maybe blast furnaces move to electric arc furnaces. So, how urgently does the industry need to pivot towards other sort of like cement, like LC3 cement, to secure its raw material supply? So, if you can share, I think the cement manufacturers' perspectives and what is kind of like the strategic direction it is moving, I think that will be very educational for us. So, Mr. Manjunath.
Thank you, Satish sir. Actually, I interacted with you, Solar Decathlon. I had met you. I got a photo with you with a cap.
Yes,
You
yes.
always look young and fresh, and to serve the country and serve on low carbon. Would like to share a few success story of JSW, a cement company among 86 building materials company in the world. We have stood number one in terms of ESG and sustainability rating last year by S&P Global. This is a global benchmark. Why I want to share that is that we are talking about the factors like the first clinker factor. The Indian average is about 65 to 70%. JSW standing at 50% clinker factor. We were 43% of clinker factor 2 years ago. We moved to 50 because like some of our plants have come in North India where the OPC production is more. Coming to the next lever, TSR. So JSW, as per the presentation of Bridges, was 6% India. We are at almost 20%, 16.5% last year we have achieved, and we are moving to 30% by 2030. So, all 80% of the products are being green products. Whatever the products like GGBS, we have the yes share, 86% market share. Slag cement, we are having almost 50% market share. So, I'm giving an example of a company which is standing on a podium on achieving sustainability and waste heat recovery system, adopting all the levers what was discussed by Pavitra madam as well as Brijesh sir. So, looking at the availability of various materials, SCMs, as per the statistics available, there is no shortage of fly ash till 2060. And slag also availability is there. JSW itself is expanding its capacity. We are one of the largest steel producer in the country, from current 40 million ton to 80 million tons. And Tata Steel is expanding, ArcelorMittal. So current the Indian over 200 million ton capacity to be 450 million ton capacity. So in India, there's no shortage of these materials. Along with that, LC3 also started. One company started, as the other speaker told. There is no support. There is no approvals in various specifications, government departments. So I am in the industry. Day in, day out, I go to the government departments, policymakers, builders, developers to adopt the low carbon material. As Pavitra was telling that bulk cement usage in the developed countries like Europe, America is very high, 80% or 85%. I don't see any people opening bags and using except maybe few applications where you cannot bring a concrete in a transit mixer. In India, still, I'm in the industry, ready mix industry also, and our adaptation, conversion of cement to ready mix is hardly about 25 to 30%. Still, we have a very long way to go because the moment the construction happens in India, India is a different country altogether. You cannot, through policy, you cannot drive because every moment a house has to be constructed in Bangalore or Mysore or anywhere except Mumbai. Mumbai's space is not there. Every owner become a civil engineer. Want to procure his own cement and you want to have his, at least mystery engineers are available, it doesn't allow them. You want to start constructing, open the bags. So these are the things. I don't, till the habit changes, we cannot change so easily. So people's habit have to change. More mechanization has to come in the construction. So when that happens, the trend, what we are talking about, moving to sustainable development using low carbon materials, and also in a policy making process, our IGBC and other GRIHA certification, there's not much importance on embodied carbon reduction because embodied carbon is one time when you construct the building, we are going to use what kind of cement, so blended cement or OPC, 4353 grade cement. Even today, developed market Bangalore itself, the bagged cement consumption is very high, about 2 lakh tons out of about 7 to 6 lakh tons. Still, bag cement is going apart from rural. So it has to change. The usage of the product should change from bags to bulk, then adaptation of high grades of concrete, high strength concrete, where we adopt the usage of supplementary cementitious material, not only in cement making, but also in concrete making. So the way forward is that it's not the low carbon cement, it's a low carbon concrete. When we move to low carbon concrete technologies from the prescribed mixes to the performance based specifications, and the new IS code which is going to come, IS 456, that is going to adopt performance based specification for all these structures. With that going forward, we will be able to move towards that. Even today, 73% of the cement in India is bulk cement, blended cement. We are not lagging behind in any way. In terms of carbon reduction, also compared to global average of 600 plus kgs per ton, we are around 540 kgs. So technology has to advance. It is a way forward how we are adopting the technology, specifications, and converting from bag to bulk, as Pavitra is telling. That is the way forward, I feel. The shortage of SEMs is not there, but I suggest that LC3 has to be promoted in a big way. And the government should give some incentives to start LC3 production, should come in the specification. One company started, I am very closely interacting with that company. My friend is the marketing head. So he did not get bulk out of that company, I believe, stopped making that cement only. So how can we create use cases? So company should, government should say, you make LC3 cement, I am going to support whatever the additional expenditures or calcination of clay is there, alerting the clay mines, everything government should do. Then only maybe after 20 years, when we feel shortage of GGBS or fly ash, we can move towards. In India, till the fire is lit, you're facing the heat, you will not change your mindset. Now, fly ash is available, GGBS is available, people don't want to change their mindset. But when everything's exhausted, then we'll get up like Y2K. This should not happen. The technology of LC3 cement and using alternative clinker technology should be developed along with carbon capture and other new technologies. We are working on that. So this is a way forward. In all the levers we have to press, moving towards green energy, moving towards sustainable procurement. All these things are very much important, sir. I think so. I covered the points, I believe.
Okay, thank you, Mr. Manjunath, for giving a fairly broader perspective and also sharing your viewpoint that availability of the SCMs may not be such a big concern. I think as per your intelligence, and I think what are some of the trends that you are seeing. I'm going to move to my friend Mr. Anurag Bajpayee. Anurag, since you work closely with developers and also on green rating certification, my question to you is that what are the biggest bottlenecks to mainstreaming low carbon cement? You have heard other panelists and in the presentation, I think is some of the drivers that should actually generate the demand for green cement, as well as some of the barriers I think that is being experienced by different sort of like users from and what the government is doing. So is it like in your sense, like is it the weak market demand? Is it the limited local supply chains? Is it concerns over performance? I think of some of these where I think the clinker content goes down, or is it like the time that it takes for the cement to set? What are or is the cost premium? So if you can quickly tell us about that, and I'll also request everyone to keep their intervention short because we may have a possibility to ask some questions for the second round, or I think some questions from the audience as well. Otherwise, I think we'll need to wrap it up, I think, in another 15-20 minutes time. So over to you, Anurag.
Thank you, Dr. Satish and AEEE for this opportunity. Am I audible enough?
Yeah, you are.
Yeah. So, sir, as you have mentioned, in terms of the specific barriers that we see in the private sector or the public sector for the maybe blended cement usage, I think in both cases, their responses are very different with respect to the cement usage. When we look at the private sector, they certainly look at the specific requirement in terms of OPC, PPC, and their major concern based on the specific design component. So if the size of the specific component or the element of the building is higher, then I think the structure design with respect to the vetting done by the institutes, they certainly refer the specific cement as part of the structure requirement. And the specific component other than these specific requirement, they go for the PPC or the blended cement component. In most of the maybe the requirement we have seen how the RMC plants they play a role, and then their major requirement is OPC, but the supply is pretty much like with the 25 to 30% of fly ash mix in terms of the blended cement requirement. When we look at the public sector, their SOR, they certainly defines the OPC oblique PPC, but in most of the tenders that we have seen, they do not clear this particular difference in terms of what they should use in terms of blended cement. They certainly look at the specific requirement in terms of durability, strength. I'll give an example so that we can have a much more clarity. For example, we did work on the green public procurement for the major PSUs, for example, NHAI and railways, and certainly the other infrastructure projects as well. And then when we look at the tenders, particularly with respect to the how the tender procurement or the it is being awarded, it is pretty much like the contractor-based procurement, and where L1 is the basis of these awards, where I do not think that they have any specific, maybe specific mention of the carbon intensity per ton or anything like this. They certainly have the very specific component, and the design, the strength, durability, all these things, they are there along with the defect liability period. And then the L1 is the basic criteria. When you look at maybe I think most of the contractors processes, they certainly have the captive RMC plants for blended cement, OPC, PPC, PSC, GBCS. And maybe I think this one point that you have mentioned, sir, the concern is the settling time. That is something which is already there, because most of the cases, particularly in the public sector, the contractor is running behind the time. And this is something which maybe sometimes, maybe I think most of the times, it forces them to use the OPC I understand when we look at the settling time, OPC versus LC3, they're pretty much like the same. But when we look at the LC3, I think based on what we have seen in one of the demonstration projects with the private sector, even if the settling time is same, but maybe I think due to the issue of carbonation, the admixture cost is very high. And that is one of the specific resistance also that we have seen in terms of how such demonstration projects not pursuing the LC3, or maybe I think having enough resistance of not pursuing the LC3 at this point of time. But when you look at the, let's say, mandatory requirement for public sector, no carbon intensity. I'll just summarize this, and then the for the infra projects, for example, railway or metro or airports, they certainly have these green building rating systems and some operation excellence, which may lead to the carbon emission. Maybe it's related to their operation and maintenance perspective, and some specific component with respect to the green energy installations as well. But that is what it is in terms of how these specific components that are being dealt. With respect to the low carbon cement, I think there's not much of the specific component which is being there. Although what we have proposed and worked with NHI, and particularly Ministry of Road Transport and Highways, we have developed the specific roadmap in terms of how they should go ahead with respect to the phased approach in terms of maybe the carbon intensity requirement. But at this point of time, I think this is something which is in the limitation. So this, I'll just pause here and then I'll go ahead and contribute later.
Okay, thanks. Thanks, Anurag, for bringing in a very, very useful perspective based on the work that you folks are doing, and also, I think, highlighting some of the challenges, either I think in terms of the cost perspective, which I think is fairly well known, but also some of the technology limiting factors that you have highlighted. Let me come to Dr. Pramod Kumar Singh. I think he has been one of the collaborators on this report as well. So Pramod ji, I think my question to you is related to the alternative fuel substitution. We have heard, I think, from different speakers, I think about the need to raise the TSR from, say, an industry average of 6% to the 20% mark. But you have worked in the sector, and you also know, I think, in terms of what are some of the technological improvements that will have to be made because of, I think, this interventions related to treating volatile impurities like chlorides. I don't fully understand some of these technologies, but maybe you can take a few minutes to highlight, I think, the challenges that the cement industry is facing or likely to face as we embark on this journey. So over to you, Dr. Pramod Kumar Singh ji.
Thank you, sir. Thank you, sir. Good afternoon.
Good afternoon.
Yeah, I would like to answer all of your questions raised. In fact, uses of
keep it a little brief.
yeah,
That's my request. Yeah, please.
yeah, sure, sir, sure. In 2025, roughly 7% was the usage of TSR. Then by 2030, this planning is up to 25%. I have certain figures. Let me share quickly. Ambuja Cement in 2023-24, it was 8%. 2030, they are planning for 25%. Similarly, ACC 9.2% in 23-24. In 2030, they are planning 28%. Dalmia Cement 23-24, it was 22. Now they are planning by 2035, 100%. Similarly, JK Cement 16.3 in 23-24, and 2030 they are planning 35. So cement industry as such, they are planning to increase it to great possible extent. So that is about the usage. Now, as far as this bypass is concerned, I have worked in a cement plant where this bypass system was there. Now, there are three volatile constituents which are dangerous for cement properties. Number one is chloride availability. Second one is the alkalis. Number three is sulfur trioxide, SO3. So generally, they will combine together to be converted into volatile. And once this alkali bypass system or chloride bypass system is there, these components will be emitted through chimney. So that way, this bypass, if some cement company has, this will not affect the cement properties adversely, and process problems will not be there because this will be emitted from the system. Right, sir? So hopefully I have answered your question. And installation of this system is necessary once these materials are high. There are limits in cement. Chloride has to be less than 0.1% for general cement. And for concrete construction, this cement should have not more than 0.05% of fluoride. Now, similarly, alkalis, this limit is not more than 0.6%. And for sulfur trioxide, as such, it is not a problem as far as cement properties are concerned, because cement can absorb a lot of SO3 in the form of sodium sulfate, potassium sulfate. Then balance, if has SO3, it can be converted to calcium sulfate. So it is not at all harmful as far as cement properties are concerned. Only thing, this alkalis and chlorides, these are to be bypassed. So I think I have answered all of your questions. And quickly, I would like to highlight certain more things. As far as this production of low alkali cement is concerned, there are five cement varieties. Number one is LC3, number two is the PPC, PSC, composite cement, and last one is this masonry cement. Now, as far as this LC3, PPC, PSC, and composite cement are concerned, strength requirement is exactly same as per the Bureau of Indian Standard. Only thing, this one of my colleague, he was talking about the setting time. So this setting time can be controlled by the addition of gypsum. Once you add less quantity of gypsum, setting time can be faster. So once somebody is using this blended cement, setting has to be faster, so that setting conception, misconception from the minds of people, it has to be erased.
Okay.
So I think
Yeah.
it is from my side, sir. Yeah.
Thank you, Pramod ji, for
Yeah.
providing, I think, your inputs on some of the pathways that I think India will need to take as we go for higher TSR. I was just looking at some of the questions that are coming through in the audience, and it looks like many of the questions are related to again the SCM content and the lower clinker ratio, as well as some of the settling time and other things. So those questions have been answered. Let me quickly go through some questions directed to some specific, I think, panelists, and I'll again request folks to be brief. Maybe limit their intervention to 1 or 2 minutes so that we can run through like 4 or 5 questions. So, a question for Karthik. So, Indian budget has announced a dedicated outlay of about rupees 20,000 crores to scale up CCUS technologies. And what do you think to deploy, I think, this effectively? The report is actually proposing carbon as a service model in which the government builds the core CO2 pipeline networks. Do you see this as a viable way to reduce upfront capital expenditure for individual plants? Or I think a better way is for the private sector to actually undertake this effort, because they can be much more faster and efficient, I think, and probably also low cost if they do it on their own. So your quick take on this, Karthik.
Thank you, sir. The first point I would like to say that I will take an example from Heidelberg CCS plant in Norway. The plant, even though Heidelberg is one of the manufacturer, it is CCS is a new plant. If you see our Indian companies, Indian finance is not a part. If you look at the past 2 decades, the Indian cement has become one of the global leaders in adopting energy efficiency technology. The reason is simple. These interventions reduce energy cost and improve the competitiveness, therefore made stronger business. Where there is a commercial case, the sector invested. However, now we are entering a different phase of decarbonization technology such as CCUS. So these guys had a much capital investment. They required it out. So already guys are like JSW and Ultratech Cement, all everybody are utilizing these kind of finance for the energy efficiency one, but not for the capital investment. So these 20,000 crores would help us if we put it up and not as a pilot or a small demo, as a bigger plant. Just like the example, like Pavitran and even Brijesh has mentioned clearly that certain examples from the global, a commercial based plant would give more confidence to the Indian sector. This could be done with this 20,000 rupees if as one of the one. And one more point I would like to bring, and then I conclude. The $5,000 million of decarbonization pledge of EU after this Indian EU trade grade. So this also could help us more financial support for these CCS technologies going ahead. As clearly mentioned by the other panelists, how the next phase of decarbonization would happen with more carbon cost. So this lever would help us. To summarize, yes, this 20,000 crores would help us. But if it is a commercial based plant is available in India, this will give it will give boost to most of the cement decarbonization. Thank you.
Okay, thanks, Karthik. Sabrish, coming to you, as all of us are aware that there are international mechanisms like CBAM, and also companies are, I think, paying greater attention to their ESG compliance criteria. So, how do you see the landscape of green financing and blended finance evolving to support Indian cement manufacturers in their transition to greener cement journey? Over to you, Sabrish, and again request you to be brief. Thank you.
Thank you, Dr. Satish. I think in terms of CBAM, the exposure of the Indian cement sector to the EU is quite small, as I understand it. But in terms of the ESG, definitely yes. And I think the larger companies are already trying to do, push ahead. For example, Ultratech was one of the first ones to raise sustainability-linked bonds in India, and the conditions of the loan also are directly leading to reductions emissions from scope 1. However, if you look at the mid to smaller sized cement plants in the country, that's where there is a lack of capital, there is a lack of concessional financing available also, because of the risk appetite and the fact that the companies themselves can't really put up that much capital as the large 2 or 3 large players can do. I think here is where we have to look at more cluster based approaches, where there are cement clusters, how can we adopt a cluster specific decarbonization approach where everyone in the cluster would partake in whatever instrument that is being deployed, so that it will de-risk it for the entire cluster and all the industries present in that cluster, and for the provider of that finance, whether it is private finance or whether it is concessional finance or a mix of both from, let's say, a larger multilateral development bank. So for the large players, existing instruments are working. We have to keep pushing them along. For the smaller ones, look at more cluster-based approaches.
Okay, thanks a lot, Sabrish, for explaining that. Coming to Mr. Manjunath, I think the study has found that I think the early stage alternative binders, I think such as SC3, they do face a green cost premium, and that has been estimated to be anywhere between say like 5 to 21%. So, how is the cement industry managing this kind of a cost barrier, and what kind of policy support do you see? I think it will be helpful to promote these kind of green cement, and how can the Indian consumers, how much do you think they are willing to absorb these kind of green premiums?
Actually, sir, this concept is wrong now. Whether you look at the blended cements or composite cement or slag cement, which are constituting 73% of the total cement manufacturing, they're available at per bag, if you take 10 to 15 rupees lesser than the OPC cost. If you go to the eastern part, the gap is almost 50 to 60 rupees, because there the availability of fly ash and slag is much more compared to the other parts. So the industry is always making these low carbon cements available at a better pricing to the consumers. And earlier speakers also said there is a strength issue. when we are making concrete, um, definitely now the new generation admixtures, PC-based admixtures have come, where you can get the same strength like OPC cement. I have challenged in certain specifications where they didn't want to use a slag cement. It's having almost 65% slag against OPC. I challenged them and designed the concrete mixers which can give similar strength like OPC cement based on the requirement. Everywhere it is not required. Wherever it is required, we have challenged and got it done. So now the kind of admixtures available, the chemical composition, the raw materials available, there is no difference between OPC cement or the blended cement. You can get the same strength in terms of quality parameters.
So
And
Manjunath ji, just very quickly, I think what you are
regarding the
saying,
LC3 cement, I just
right,
want to come
LC3
back to you.
cement,
Mainly, LC cement has not taken off in India. It takes a little bit more time to take off. More and more manufacturers should start. If they have to put separate calcination plant for the clay, and maybe additional investment is required. If all the companies start manufacturing, if the government allocates certain mines to them, then it will be time to start LC3 cement. But already blended cements are available, composite cements are available in a huge quantity in India. There's no problem at all. LC3 has to take as a cement, as a product. So that for that, lot of efforts have to be done from government side also. They may have to tell the cement manufacturer at least 10% of your product should be LC3. Unless that framework comes, it takes a little bit more time to the manufacturer to adapt to LC3 cement because of the initial cost of investment for putting the calcination plant for the clay.
Okay, thank you, Manjunath ji. Anurag, I think what you described, I think when you were saying that, I think although the provisions are there for OPC, I think sometimes the cost can become. But what we are hearing from Manjunath ji, and also I think in our stakeholder consultations, I think we have heard that the cost premium between, I think, PPC and OPC is not that much. LC3 could be a different story, as I think all of us know. So, do you want to just quickly clarify? I think what you were talking about. I think in terms of using some of these low carbon cement adoption, and how is it coming into the way of like green public procurement?
Yes, sir. So as of now, sir, the cost for the OPC is, let's say, 300 rupees per bag, and PPC is 285 rupees per bag. In terms of LC3, certainly there is a supply chain issue because there's only one manufacturer who is supplying, but still the cost with the premium is coming close to 300 plus only.
But Anurag, is there a green premium delta that you are saying? I think many people that we speak to, they say that we can get, I think, OPC and PPC almost at the same price, and sometimes OPC is also cheaper. So that's the premise of my question. That what you are talking about, is it like because there seems to be a disconnect between what you are saying and what I think Manjunath ji was also
Sir,
just speaking.
100% the blended cements are cheaper than OPC cement across India. Go anywhere. It is not OPC is costlier. LC3 cement, only one manufacturer where it become a premium, want to procure that, I only want to use that. But whatever LC3 benefits are there, same thing is being offered by other blended cement. So the customer will go like, okay, you want to reduce the carbon. If you are using slag cement, which is having 65 to 68% slag in this thing, that is the lowest carbon footprint cement in the whole world. You cannot beat that carbon footprint with that product. So they
So
will go for
Anurag,
that, which is
yeah,
available at cheaper cost.
okay, yeah, your
It's
your
just like I want to wear a Rolex watch. So our LC3 no, because it's not available, it's a Rolex watch. So you have to
hmm,
pay the premium. That's it. Nothing else. If everybody start
okay,
manufacturing Rolex watch, it becomes cheaper.
yeah, okay. Anurag, yeah, quick views on this.
So, in most of the cases, I also agree with what Manjunath ji is saying in terms of most of the cases, such contractors or the projects, they use the RMC, and based on the specific grade requirement, and they procure OPC, and then the mix, let's say 30% of fly ash, it makes the blended cement component less costly. That is what the bigger such projects they are there. In terms of the green public procurement, when we look at the tendering process, they have always mentioned OPC oblique PPC. They have never mentioned the PPC only, and no even the specific mention of the blended cement or low carbon cement or any such terminologies as well. But by all the means, we have understood that they have always maybe they have to procure the OPC just because of the least settling time that is being asked by the client to them to fulfill.
Okay. All right. So I think we have 5 minutes to overtime, and we would like to wrap up. I think this webinar. And before I do and pass it on or ask Brijesh and Rohan if there is anything, I do want to take this opportunity to thank all our panelists for sharing their expertise and insights. I think into this very very important. Decarbonization story. And we all know that India is building about 1 billion square meters every year. So cement and steel I think usage is not going to decrease anytime soon. So it's really important, I think, that we all work towards, I think, making sure that the technology evolves at a rapid pace, and there are public policies and financial incentives that are being provided to the industry and to the end consumers. So thank you again very much for your time, and to the audience for I think listening to this important webinar. Brijesh, back to you. Do we have any other things before we wrap up this webinar?
No, sir. We have
Okay.
concluded everything. Yeah.
Okay. All right. So thank you very much, everyone. And again, I thank you for your participation and for your intervention. Bye.
Thank you, sir. Thank you.
Thank
Bye.
you. You bet.
Nice.
Thank you.
Bye, Satish sir. Bye.